Oke, Assalamualaikum warahmatullahi wabarakatuh. Thank you again for coming in the synchronous lecture of asset management. And for today, what we're going to discuss is managing the asset-related risk. So as you understand that the asset management is the process of balancing the cost, the performance, and the risk of the asset. So regarding with the cost, we have discussed about life cycle costs. Okay, maybe in the last 3 meetings. And in the last 2 meetings, what we have discussed is about how to maintain the performance of the asset regarding with the maintenance. And then what we are going to discuss today, like I mentioned, we are going to discuss about how we can manage the risks related to the asset. And by the end of this session, I'm going to provide a case study from a research that I have presented in an international conference. A case study related with how we can apply asset management. How we can apply risk management to manage an asset. Okay. Before we continue further, I will remind you briefly about the conceptual model of asset management. So actually, we haven't discussed the conceptual model of asset management in detail, but if you can see there, there are actually 6 groups of asset management in the conceptual model of asset management. The first group, as you know, is here. Here is organization and people, and then strategy and planning. The third one is asset management decision making, and then the fourth one is asset information. The fifth one is life cycle delivery, and what we're going to discuss today is in that group, risk and review. Okay, so actually, risk and review is an integrated part of managing the asset. All right, in the group 6 of the conceptual model of asset management, yeah, you can see that there are at least 9 subjects. Yeah, from risk assessment and management, contingency planning and resilience, and so on. Okay. So if we talk about risks related with asset, actually there are maybe 100 or perhaps 1,000 risks related with asset. So if we talk about risk of the asset, we can see just these 4 pictures, for example. Yeah, for example, is flooding. This one is also one of the example of risk related to the asset. Fire, and then also in here, this is commonly happen in wind farm. Okay, and then maybe you will be a bit surprised that in some perspective, regulation, standard, compliance, government law, government's policy is actually also can be considered as risks of assets. Okay, so what's it actually risk? Yeah, so risk is based on ISO 31,000. Risk is actually, if you can read here, apologies in bahasa. So risk is actually the effect of uncertainty on objective. That's the definition of risk from ISO 31000. As for your information, ISO 31000 is ISO that became the international standard for risk management. So based on ISO 31000, once again, the definition of risk is the effect on the effect of uncertainty on objective, and then the effect could be positive or negative. So uncertainty itself is the situation of or the result where there is lack of knowledge or lack of information. Yeah, in this sense, yeah, if we want to reduce the uncertainty, if we want to reduce the uncertainty here, what we can do is we have to collect more information or we have to acquire more knowledge. All right. If you check on this definition where the risk is the effect of uncertainty on objective, yeah. So there are some variable that we can derive from that definition. The first one is uncertainty itself, or in other words, we can say is likelihood. So risk includes likelihood. Means that if we have higher degree of likelihood, it means that the risk is also could be higher. Risk, it also has consequences. It also has consequences. If the consequences of risk or the degree of consequences of the risk is higher, it means that the risk is also higher. Okay. In some situation, risk also include exposure. If an event or a risk event that is considered or include the exposure as one of the variable, yeah. If the degree of the exposure is higher, it means that also the degree of the risk is also higher. Yeah. Or in a simple mathematical model, we can, develop a simple mathematical model which is risk equals to consequences times exposure times likelihood. Means that if one of the variable there or the degree of one of the variable there is higher, yeah, it leads to a higher risk. With the same sense, if we want to reduce the risk, we can do it by reducing the likelihood or reducing the consequences. If we want to reduce the risk by reducing the likelihood, and likelihood or uncertainty is the impact of a condition where there is lack of information or knowledge. If we want to reduce likelihood, we can do it by acquire or collecting more information or more knowledge, more complete information or more complete knowledge. It can lead us to a lower degree of likelihood that leads to a lower degree of the risk. Okay, so this is the diagram for a simple risk assessment. So risk is actually, yeah, based on ISO 31000, it only have at least two variables, severity or consequences here, and likelihood. Severity and likelihood. Yeah. So if we develop a simple diagram that consists of 4 quadrants, yeah, or 4 situations. Yeah, the first situation of low frequency and low impact. Low frequency means low likelihood. Yeah. In some cases, in some sense, likelihood is kind of probability. Probability is frequency divided by the number of events, or n. Means that if we have high frequency, it will lead to a high probability or high likelihood. So in first quadrant is a situation when there is low frequency and low impact. The second one is high frequency, high impact, high frequency, low impact. Sorry. And the third one is high impact, low frequency, and the fourth one is high impact, high frequency. Okay. So we can map a risk event or some risk event into this kind of risk assessment diagram, or some people call it a risk map or risk assessment matrix. Yeah, and this is the example, the complete example of risk classification matrix, or as I mentioned, some people call it as risk map. So as you can see here, there is a severity or impact of the risk and probability of the risk. And for each variable, for each component, or for each factor, there are 5 different levels. In the severity, there are level 1 until level 5. Level 1 is negligible, level 2 is marginal, level 3 is moderate, level 4 is critical, and level 5 is catastrophic. In the probability, yeah, they're also divided into 5 levels: rare, unlikely, possible, likely, and almost certain. The number you can see in each box here is actually the result of multiplication of the severity and probability. Take, for example, in this cell, medium, the number showing there is 9 is actually 3 times 4. Okay. The number here, for example, in this cell, is the result of multiplication for negligible and unlikely, 2 times 1. Okay. And then the result of multiplication, or every cell there who has a number higher or equal than 10. This is only for example. Higher or equal than 10 is considered as having a high risk, and then represented into a cell with red color. So if you see here, cell with red color is the cell which have 10 more than 10 score in each boxes. Yeah, and actually we divided into 3 different color: green, yellow, and red. Red is the risk who has, or the cell who has a high risk. Yellow is medium, and green is a low level of risk. Okay, and then what we need to do is we will identify risk event, and then identify every risk event, the severity or the probability of every risk event, and then put it into the risk classification matrix. Okay, I give you another example of risks and consequences. So consider we have a car for going to work. So if there's a broken car, we have two options. We can absent for working, and or we may lose some project, or we going by taxi, which is more expensive compared to using our own car. To maintain the car, we can have two maintenance policy: regular maintenance or breakdown maintenance. Yeah, you remember preventive maintenance, regular maintenance or breakdown maintenance. So actually, preventive maintenance is focusing on managing and reducing the probability. Okay, so if we doing a good preventive maintenance, means that it will reduce the probability, which leads to the lower degree of the risk. Where breakdown maintenance policy is tends to manage the consequences of the failure. So there's two examples of how maintenance, preventive maintenance, and breakdown maintenance from the perspective of risk management. So it's also a simple risk assessment that I'm going to inform you in this slide. So for example, an asset manager is responsible for maintaining the building, which houses of some critical electrical equipment. If water ingress into the building, it will result in certain failure of the equipment, and consequences will be that several thousand people will be without power for about 24 hours. So imagine there's a building, and that building consists of many electrical equipment. So if there are water ingress or there is water ingress into the building, it leads to the failure of the equipment, and there will be 1,000 of houses without power for about 24 hours. So how does the asset manager quantify the risks associated with the water ingress? And how does the manager determine the best way to minimize the cost of the organization while also maintaining the performance? Okay, for that simple cases. So as you know that what we need to do is we need to acquire more information, yeah, regarding to the risk. So from the information, there are two possible water ingress exists. The first one is leakage of rainwater through the roof, and the second one is flooding from the nearby river. Okay, and the manager tries to collect more information, actually to reduce the likelihood. So roof of the top of the building have a design life of approximately 25 years, and its current condition suggests that it is likely to leak in the next 5 years. Yet the consequences of both leakage and flooding is pretty much the same. Okay, so the probability of the roof leaking, yeah, after calculating, is 25 times higher than the probability of the river flooding. So the risk associated with the roof leakage, therefore, is 25 times higher compared with the flooding. So the optimal mitigation to reduce the risk of the failure of the electrical plants as the result of water ingress is to repair the roof. Why? Because the probability is higher with the same consequences. Yeah, the consequences is the same. but the probability of the roof leaking is higher than the flooding. So the mitigation that proposed by the manager is to repair the roof. That's a simple case study of the risk. So how actually risk management work? Okay, I take this figure from ISO 31000. I think it was published on 2009. But if you check the newer version of ISO 31000, the figure is pretty much different. So the figure consists of three different parts. On your left-hand side is the principle of risk management. Actually, there are 11 principles of asset management. From A, create value; B, integral part of organization process, and so until the last one, the K, facilitates continual improvement and enhance of the organization. Okay, from the principle of risk management, and then is transformed into the mandate and commitment. In ISO 31000, mandate and commitment is you can find on clause number 4.2. So we go back to this figure. On the middle part of the figure, it consists of the framework of the risk management. The framework of risk management. So it's actually similar with plan, do, check, action. And of course, that I believe that you're already very familiar with. If we talk about plan, do, check, action, the principle of the risk management become the mandate and the commitment. Yeah, this is the target of the plan, do, check, action cycle. And this one is the plan section. This one is the do. This check, and this one is the action or follow up. Yeah, and the number of the standard process of each component of the plan do, check, action you can find on this clause 4.3, 4.4, 4.5, and 4.6. Okay, and then the framework of the risk management, especially on the do section, yeah, in this one, and then transform into the process of risk management. Yeah, so this one will be can be highlight into this figure. Yeah, so actually in the process of risk management, it consists of several main steps. The first one is establishing the context. Okay, and the most important step in the process of risk management is the process of risk assessment here. The risk assessment consists of three process. Risk identification is the first one, risk analysis, and risk evaluation. And then the last one is risk treatment. Well, we do the process of risk management from establishing the context, doing risk assessment, and risk treatment. Okay, it should be communicated and consulted with the expert or any stakeholder, any related stakeholder, and also need monitoring and review as well. Okay, I will focus on the process of risk assessment actually in the middle. So there are three main steps of risk assessment, which are risk identification, risk analysis, and risk evaluation. So risk identification is actually the process of finding, recognizing, and describing the risk. So risk identification is also involved the identification of risk sources, risk event, their causes, and their potential consequences. And then risk identification can also involve historical data, theoretical analysis, informed and expert opinion, as well as stakeholders' needs. And the source of risk, the thing that you have to remember, it could be from external or internal organization. So in the process of risk identification, what we need to do is we find the risks, recognize the risks, and describing the risks. After that, we need to identify the source of the risk, the causes, and potential consequences. Yeah, the way to identify the causes, we can use some uh, tools that you're already familiar, like fishbone diagram, or you can use FEMEA, or you can use 5 whys, for example. Okay, this is identification. And the second one is risk analysis. Risk analysis is a process to comprehend the nature of risk and to determine the level of risk. Comprehend the nature of risk and determine the level of risk. So in the risk analysis, it provides the basis for risk evaluation and decision about risk treatment. It also includes risk estimation. And the last one is risk evaluation. So risk evaluation is the process of comparing the result of risk analysis with risk criteria to determine whether the risk and or its magnitude is acceptable or tolerable. So risk evaluation assists the decision about risk treatment. Okay, what I'm going to give you today, I mean, in this part of the lectures, is give you the result of my research. Yeah, the research entitled Design of Risk Reduction Strategy based on risk assessment and cost benefit approach. So in this research, what we have done, if we combine between first lean concept, if we talk about waste reduction, it wouldn't be far from lean concept. And then another approach, if we use risk management approach. And the third one is we use kind of cost and benefit analysis that you can find in engineering economics, as I remember. And this research has been presented in international conference last year. Okay, once again, the title is Design of Risk Reduction Strategy based on risk assessment and cost benefit analysis. Okay, so this is the background of the research. So in 2017, the demand of the white sugar nationwide is estimated to reach about 5.7 million tons. That consists of 2.8 million tons of industry needs, and 2.9 million tons for household consumption. But unfortunately, the national production is only 2.2 million tons, meaning that the country is lack of supply for approximately 2.5 million tons. Okay. But the government applies VAT, value-added taxes, VAT-free for this commodity, for the import. Yeah. The effect of the VAT-free policy is the price of the imported for the imported item from the market. The price in the market is about 7,500 to 8,000 per kilogram, which is lower than the production cost of the local manufacturers, which is approximately more than 10,000. With this situation, yeah, businessman tends to import the commodity, yeah, because it's cheaper compared to manufacturers the commodity themselves. So why the manufacture cost is high is mainly because of the high price of fertilizer and high cost of production process. So what we're going to do, what we have done, if we propose a business process re-engineering of the whole process of the manufacturing, yeah, we have observed it, and we propose a business process re-engineering. And what we have found and what we have designed is actually kind of mobile equipment, as you can see there. The detail of this one, you can contact me and we can discuss it further. Also, we have applied risk management approach. We have proposed better maintenance practices. We have proposed asset management principle. We have proposed a new maintenance project management schedule based on genetic algorithm in order to actually reduce the high cost of production process. Okay, but in this research, what I'm going to introduce to you is actually how we can use lean manufacturing approach, as I said, to find the waste. And then we can combine the lean manufacturing approach with the risk management approach to find the mitigation of the waste reduction. So in the perspective of risk management, the waste is actually considered as risk. And then we have to solve the waste or reduce the waste or remove the waste or eliminate the waste from with the steps or the process of risk management. The result of this process is actually some mitigation strategies. And then the mitigation strategies need to be analyzed. Is it feasible or not? Because we need to compare the consequences with the cost of the mitigation strategies. If the cost of the mitigation strategies is higher than the consequences of the risk, it means that the mitigation strategies is not feasible to do. But if the cost of mitigation strategies much more lower than the consequences of the risk, this is a good sign that the mitigation strategy is feasible to do. Okay, this is the step that we have done. First, we identify the waste with the lean approach, and then the waste is considered as a risk that need to be assessed. That's what we do in the second step, doing the risk assessment, and they identify the root cause and develop a proposed improvement. Okay, from the first step, we have found some ways that we categorize into the 9 ways of lean. As you can see there, this is the first waste, this is the second one. I think this is the 4, 5, 6, and 7. Yeah, and this is the type of waste or the category of the waste. Okay, and then what we do next is we uh, assess the risks to see the likelihood and consequences. It is done by doing a simple focus group discussion to determine the likelihood and the consequences for each risk. And the result is then uh, plotted into the risk map like this. And we found that there are three here. There are three, uh, what is it? Risk event with a high degree of risk, which is W2, W4, and W5. Okay, and then what we do next is we need to find a potential root causes for each high degree risk. This is an example of why we do that. Yeah, here is the potential risk. Okay, and then we find the category of the root cause. Okay, and then we identify the root cause as well as the frequency of each root cause. And we can see that wet raw material providing a high frequency of risk is also related with asset. Yeah, because in this case study, you can see that there is a decrease of performance. Yeah, that uh, caused by the low performance of an asset. Yeah. And then that causes is actually the root cause of the low performance of the asset is because of the wet raw material, because it's kind of a boiler. And after we see the, after we found the root cause, we propose some mitigation strategies. If you can see that, okay. You can pause this video to see more detail on the mitigation strategy. This is also the mitigation strategy. Yeah. So if you can see here, there we provide some mitigation strategies as well as this SOP is one of the mitigation strategy. Yeah. And what we're going to do next is we calculate the cost and benefit of the mitigation strategy. This is the detail of the cost benefit calculation. Okay. Okay. If you want to see more detail about this case study, what you can do is you just Google it with this, what is it, keyword, just the title of the paper, design of waste reduction strategy based on risk assessment and cost benefit approach. Just type it on Google, just Google it and you can find, or you can find the paper, you can download it for free. Yeah. If you want to see more detail about how we identify the risks, how we assess the risks, especially related with the asset, and how we develop a mitigation strategy, and how we calculate the mitigation, the cost of the mitigation strategy. Okay, that's all for today. Thank you very much, and Assalamualaikum warahmatullahi wabarakatuh.